Number 87 in your classwork for analytic geometry asked to prove that the two triangles are congruent. So we have, from given information, we have that the ray J or GJ bisects the angle OGH. So if JG bisects OGH, that means that these two angles will be congruent to each other. So we have so number one was just given information. 2, we have that the angle formed by OJG, so OGJ, this is very confusing, is congruent to HGJ, it's congruent to angle HGJ, and that's just from the definition of an angle bisector. Then we have that GJ is congruent to GJ, so these two segments are congruent to each other. That's just a reflexive property. Of congruence. Then we have, from the distance formula, we have that OG is equal to some number. So that would be using the coordinate grid. So we have that our distance is from this point, which is at the origin, to this point G, which is at 3, 1, 2, 3, 4, 5. So this distance would be 3 minus 0 squared plus 5 minus 0 squared, which is the square root of 9 plus 25, giving us square root of 34. So OG is the square root of 34, and HG is given by a distance of from H to G. H is at this is 6, 0, and G is at 3, 5. So we have change in x, 6 minus 3 squared plus 0 minus 5 squared, which gives us a distance of 3 squared, which is 9, plus negative 5 squared is 25. So we have, again, square root of 34. So the square root of 34 is equal to the length of HG. Then OG is congruent to HG. So this is just the definition of congruence. So definition of congruence. And now we can say that we have one pair of corresponding sides that are congruent, another pair of corresponding sides, this shared line GJ, that is congruent, and one shared interior pair of angles that's congruent. So by SAS congruence, we can say that the two triangles are congruent to each other.